This is module number 5. It's an overview of management practices, just a few examples, and NRCS practices. For those that are not familiar with NRCS, it stands for Natural Resources Conservation Service, and it is an agency within the USDA. Our roles as partner biologists, when we were introduced earlier, is to provide technical expertise on certain topics. Of course, here with the Xerces Society, our staff that work as partner biologists are providing expertise on conserving pollinators and beneficial insects. And so through that, what we do is we go out to a site, we meet with a producer. This could be, a large farm, a small urban farm. And we talk about their goals for the land and what we call resource concerns. And obviously soil is a very important resource, whether you're growing on a large or small scale. What we do with that information is put it into a conservation plan and give them suggestions on how to address resource concerns so they can meet their goals. And we'll talk about a couple of those practices at the end. If you want a longer list, in the appendix of the Farming with Soil Life handbook, there's a big, oops, that's not showing up there. There's a big table. Sorry, I can't show you that very well. At the end, that mentions many more practices. These practices, the technical assistance is available to anybody. So if you have questions, you could call your local office. If you need help getting in touch with your local field office, you could contact me. And a lot of these practices come with programs that provide a financial incentive to implement these conservation practices. And that money is through the Farm Bill funding. We talked about insect decline earlier. There are a lot of drivers for insect declines. A lot of them are interacting, right? And so here is just a really basic overview of some of those declines and what we can all do to kind of prevent this. Of course, habitat loss is a big driver, right? The loss of the resources these animals need, whether that's flowering resources, connected habitat, the ability to move throughout the environment. And that's something that we can all do is conserve and create habitat. The good thing about insects is that they're small, and even small habitat plantings can provide really large benefits for these animals. So unlike larger mammals, they're pretty accessible and easy to conserve, even in a small backyard. Reducing our reliance on pesticides. A lot of the insecticides that are used for pest control do not discriminate against other animals, right? And so these insects are sensitive to them, and a lot of things we use are highly toxic. Disease and introduced species, so managing those risks. Here you can see a quad of bumblebees. This could go for honeybees or other insects that are reared and raised in captivity. Once they're out in the wild, they can spread disease. The facilities for rearing insects are not regulated, and so some of them are not using sterile techniques. And then climate change. And something we can do for that is plan for species and habitat diversity. So biodiversity is a good defense against changing climate or extreme events like we're seeing with flooding or drought. We saw this earlier, but soil invertebrates are in urban soils, and they can be very diverse. And these animals are sensitive to soil disturbance, heavy metal contamination, pesticides, which I mentioned in the last slide, irrigation, fertilization, the type of plant communities and cover, the way that area is being managed. And so we want to promote healthy soil. So these soil health practices that support soil life and other soil health principles. And so this can be minimizing disturbance, maximizing biodiversity, maximizing soil cover, and living plant roots. This is what's feeding the soil, having those continuous roots there, having that biodiversity, different plants, different types of plants. We could see that above ground if we plant a diverse hedgerow or a diverse meadow. But below ground, that root diversity is really important as well. Our plants have different types of roots, different size roots. And so a lot of our native plants have very deep roots that are great for soil infiltration and or water infiltration, holding the soil to prevent erosion and feeding those animals underneath our feet, I should say. So some of the effects of tillage, fertilizer, and pesticides, and when we're looking at soil disturbance, whether, this is a large tillage implement here, this could also be, a walk behind tiller. You are disturbing the soil. You can cause desiccation. You're breaking that fungal hyphae, those connections underneath the soil, destruction of tunnels, burrows, and nest sites. You're changing some of the physical properties of the soil when you're doing this disturbance. And of course, direct harm, right? All of those animals we've seen in that great pictogram that both Stephanie showed earlier, these implements can be directly harming them by crushing them or killing them. Indirect and direct effects of pesticides. And so same thing. You might have a direct effect, which really is instant mortality. These animals are exposed to toxic pesticides and they die. Or in some situations, the pesticides are leaching into our soils or they're in our plants. We'll talk about systemic pesticides. And these animals are consuming it or encountering it that way. And over time, they're getting small doses of this toxic poison, and that can affect things like foraging and reproduction and neurological effects. And so if you're not eating and foraging and reproducing, that is fatal to your insect community as well. I have two examples here of pesticide exposure pathways. One of the largest group of insecticides that are used currently are neonicotinoids. These are systemic, and so they're taken up into the plant's vascular system. They're highly toxic to bees and beneficials. The thinking was, they're taken up by a plant. If a pest animal comes and chews on that plant, they'll get a dose of poison. Unfortunately, these insecticides are also expressed in floral resources like pollen and nectar. Like you can see here on the far right of the picture here, this bee is getting exposed through feeding. But that's not the only way. These pesticides leach into the environment. They could get into water. They move in our soil. Some of them are very long lasting, and so they have a long-term exposure. And so these insects can encounter pesticides those ways too, which sometimes are not as obvious. We have two publications, larger publications on this and several others on our website that I'm just showing here in case you wanted to look up more information, a compilation of scientific literature that's really nicely boiled down in these two publications. One is focused on pollinators. Others are focused on other beneficial insects. And this isn't just at the farm scale, right? This is happening in our neighborhoods and residential areas as well. So this is a firefly example, which we talked about earlier. And so garden and lawn treatments that are readily available at a garden store for homeowner use. Some of them are neonicotinoids and or very highly toxic chemicals as well. And so as we're treating lawns and other things, again, leaching into the soil, affecting, not just fireflies, but these other animals that are living underground. So when we're talking about soil disturbance, you know, obviously low soil disturbance means more soil life. High disturbance, less soil life. And as we look down on this table, the same thing goes for pesticides, you know, no or low use, you see more soil life, less, or high use, you see less soil life. And it goes on and on for heavy metals, irrigation, fertilization, and plant communities. So I'm going to talk about a few practices in the time I have left here. But before I do, here's another open question. So this is a question you'll reply in the chat box. What are some of the practices or particular practices that you have implemented or seen implemented to support soil life? So give everybody a minute to answer there. Here's my chat box. Leaving leaves, all organic, no-till pesticides. Less to no-till, correct. Mulching. A lot of the things that are being mentioned here are practices that are offered through NRCS. Mulching, low-till or no-till, cover crops, composting, correct. Please keep answering in there, but for the sake of time, I'm going to move on. As I get this box out of my way, sorry about that. So here are some practices that, you know, are used to minimize soil disturbance. So limiting, reducing tillage or rotating areas that are being tilled. Limiting chemical disturbances. So a lot of people answered this in the chat. You know, non-pest species take a long time to recover from pesticides. And so, as you can imagine, pests often have multiple generations per year. As we were talking about the insect profiles, a lot of these animals have one generation per year. So a disturbance like tillage or pesticide exposure, it takes them a long time to rebound from that. And that can cause population crashes and declines. Using integrated pest management, such as prevention and pest exclusion, these non-chemical means for controlling pests are great options. Maximizing cover. So whether you're on a farm or in your garden, the more plant diversity you have, the more dense cover you have, like you could see here in the top picture, this cover crop mix, it's going to help, again, hold the soil, reduce erosion, help infiltration of water, and provide that organic matter into the soil. So if you're harvesting a crop, planting a cover crop when you don't have something growing there, and this could be done on large scales or simply in your garden or garden bed. Living roots growing throughout the system. I got ahead of myself a little bit. This is the garden bed example. So reducing those fallow periods with no cover, growing long season crops, having crop diversity, planting cover crops and perennials. And maximizing biodiversity overall. So taking out parts of lawn that might be able to be planted to wildflowers or native shrubs, like you see in this bottom picture here. It's one of those great options. Same concept here, but with hedgerows. So if you have long linear areas, you know, a lot of people overlook the value of planting permanent trees and shrubs. You could integrate wildflowers into that as well. Beautifies the landscape, feeds pollinators, also has those soil health benefits. Somebody mentioned beetle banks earlier. And so beetles, ground beetles, like to kind of hunker down in these tufts of these bunch grasses at the base. And so simply having a mounded area, could be on the side of a field, it could be running through the field at certain increments of native bunch grasses, is a really easy way to support not only ground beetles, but spiders and other beneficial arthropods. Managing artificial lights at night is critically important. This is important for fireflies. This is important for other soil insects. It causes them to move away from the habitat towards the light, which can be hazardous, reduces mating, can disrupt courtship. So having, motion activated lights, using less lights is really important. And I just have 2 more slides here. I know we're talking about urban areas. NRCS does support urban agriculture. There are a lot of programs and initiatives. And so when you get the slides, you'll have these links here where you could contact your local service centers. And this is just an overview of a couple practices, one that we call conservation cover. There's also another one called wildlife habitat planting, where you could use pollinator mixes of perennial species, cover crops, which we talked a lot about. You can see this buckwheat here, multi-species cover crops. This practice for smaller farms pays by the square foot. Field borders, same concept, hedgerows, herbaceous plantings, and then conservation crop rotation. So rotating those specialty crops, and that can include cover crops in that system. And that is all I have.